Everybody. It's 11 o'clock on my screen, so we'll get started here. As a reminder, this presentation will be recorded. It will be available on our community page after this presentation is over. We'll do some edits, etc. My name is Vlad. I'm a developer relations manager here at Acumatica, and today I'm joined by Nicholas Bova, our speaker and presenter for today's Coffee and Code. Do keep in mind that depending on your level of Teams access, this is determined by your IT department. You may or may not have access to the chat, the Q&A, etc. So if you are running into issues with that, please reach out to your IT department. But other than that, we do have the chat window, the Q&A window, and we'll be doing periodic Q&A as Nicholas allows. So if there's any questions, please post it inside Q&A, leave general comments into the chat, and Nicholas, the floor is yours.
Sounds good. Thank you, Vlad. I'll go ahead and share my screen. I'll get the slides going. Let me know. Let me see. Did the screen share work? All right, there we go. Let's see. Get a response from everyone in the chat. Is my screen share working okay? And hopefully this is also a good size text for everyone, since we'll be taking a look at some source code today. Be taking a look at the Acumatica website, so hopefully this all looks good to everyone. Getting some thumbs up, so I think we're all good. If that's the case, I'll go ahead and get started. So thank you everyone for joining us in today's Coffee and Code session, where we'll be discussing dependency injection. I'm Nicholas Bova. I'm a senior software developer with the services team here at Acumatica. The day-to-day primarily focused on developing customization projects and customization code. I've also worked on various different special projects in the past as well as doing these kinds of webinars and summits sessions as well. So go ahead and get into today's agenda. First things first, we'll be going over a high-level overview of what dependency injection is from a design pattern standpoint, going over some abstract examples of some abstract classes, both without and with dependency injection as a design pattern. Be going over to the more specific implementations of how Acumatica works with dependency injected components within the framework through a library called Autofac. From there, we're going to be going over a demo of a logger service that shows off the various different methods and interfaces that Acumatica and Autofac provides to be able to work with external services within customization code. And then at the very end, we'll be going over some best practices when you might want to use this kind of approach to your own code, and when you might want to find alternatives depending on what you're trying to do and what kind of application you're trying to develop. And then, of course, custom area will be going into a Q&A at the end as well. And in general, I'm looking forward to today's session. I think a lot of webinars and sessions that we present here at Acumatica, they're very specific to the Acumatica framework, and specifically for developers who are writing customizations within Acumatica. They're very specific to the Acumatica ecosystem. And this session will be going over a lot of material that's very much that, very much about how you can work with any external services or any integrations you might want to work with within your customization code. But also a lot of the material that we're covering in today's course is also going to be very broad and very applicable to any other projects you're working with outside the ecosystem. I mean, any application that you're developing within an object-oriented programming, you could use the information within this course, as a baseline and as a guideline to help improve your code quality and write more maintainable, testable code. So it's enough of the introductions. We'll be going into what dependency injection is, and what it is from a very high level is it's a design pattern. Like I just mentioned, it's a way of separating out the interface that your application is going to be working with from application code from the actual implementation of that service itself. And to be able to illustrate what that actually means, I have an example here of a database service, one where we're working with dependencies that are not injected into the class, and one with an example where we're implementing a dependency injection pattern. So imagine as a high level sort of example here. Say, for example, you have some sort of application that's integrating with some sort of external database. Say you're writing some CRM code, and you're perhaps taking customer data, cases, opportunities that are stored within an external database, and you're processing that data and importing them, say, into Acumatica or to some other ERP. In order to actually connect to this database, we need some sort of a component that allows us to connect to the database provider. And then within that service, process that data and get it ready to import within our application. In this example, we have a database service that implements a Microsoft SQL database provider. And since it relies on Microsoft SQL, we have to do some sort of creation within the database service object itself. In this case, within the class constructor for the database service, we simply create a new instance of that Microsoft SQL database provider that will perform the task of connecting to that database and providing any methods and any interfaces that our application needs to work with this external database service. And with an example like this, if we're working with smaller applications, more simple applications where we know we're only ever going to be working with this one database provider, this is going to work perfectly fine. Where this could pose issues in the future within our application is if we tend to scale. And in particular, with a database service, we might want to extend out our application to be able to work with other database providers in the future. So maybe not just Microsoft SQL, we want to work with Postgres in the future, or MySQL, or Oracle, or some other open source database standard. We might also run into issues in the future if we need to unit test any methods, any other components within our application that rely on this database service to be there in order to function properly. And within unit tests in particular, too, you want to be able to verify that all of our methods work correctly and in a deterministic way, such that if we have any inputs to methods within our classes, we want to make sure that we be able to get the same outputs given a certain set of inputs for those methods. When you're working with a database, that makes things very hard to keep consistently. You have methods within our program that are going to change the data that's on the database, and so we need to roll back whatever commits we make to the database in order to make sure our unit tests function properly. It makes unit testing a nightmare when you go with that approach of relying on connecting to concrete implementations of external services. And so in terms of being able to address these kinds of problems, this is where the dependency injection pattern comes in. So we take a look at the example on the right here with the example of our database service where we have a dependency injection pattern. Instead of relying on the database service to be able to create and maintain that reference to the database provider itself, what we do instead is we pass in an interface to the database service. In this case, we have declared an interface called iDatabase provider. This specific example, we've kept it very simple. So it just has a connect method that takes a path and an authentication token, returns back true or false depending on if the connection was successful or not. And we also have the ability to send it any sort of generic SQL query as well and retrieve back some sort of response. So using this interface, we can implement a concrete version of that interface through any sort of class declaration. So we could have, say, for example, Microsoft SQL database provider that implements this interface like we had in the previous example. We could have various other different implementations of this interface that we can implement as well. Or also, for the sake of unit testing, we can also create a mock version of this provider. In this case, the dummy provider that's specified in this example right here, where we have implementations of the methods that we have defined in our interface for connect and send query. Where in this case, they simply always return a successful response for connection to the database and always returns back the same result for send query as well. Again, basically providing that deterministic output that we want to be able to have with any mock services that we supply to components that we use throughout our application, which is what we do here. And this particular instance of the database service that we have right here, within its constructor, it takes in a concrete implementation of the iDatabase provider that's necessary in order to be able to create an actual object instance of this given class. And this is an example of what's called a type 1 IOC, so a constructor injected dependency, one where we have a dependency that's required in order for the component to work. Thus, we have within the constructor specified the interface as a parameter in order to actually create an object instance of that specific class. And so that's dependency injection on a very high level. To go over the benefits of what dependency injection gives to our application, number one is modularity. Like we had talked about previously, we can extend existing components with new implementations of existing interfaces to be able to provide new features and functionality. So in our previous example, we don't have to be tied to, say, just one database engine. If we're writing a database service, we can make it so that it works with others in the future if we want to extend out support and extend out our application in the future to provide more value and more functionality. With the dependency injection pattern, we also get more testability as well. So we're no longer tightly coupled between the interface that our application works with for any external services and the concrete implementation of those services as well. This allows us to be able to supply implementations of services that are deterministic, allow for unit testing of methods within the component. And in general, I think it also makes for more maintainable and more easy to write code as well, depending on the kinds of applications you're writing, especially any applications that are medium size, large size, enterprise level applications, one where you're working with multiple developers. Dependencies and components, since they're decoupled from one another, definitely allows for much easier software architecture where you could have multiple developers work on different components within the application in such a way that they don't need to necessarily know about the other components of the application and rely on one another in order to get the code within the program working as intended. And so that's a high level sort of a explanation of what dependency injection is. And with following this design pattern, because of how it's decoupled from the creation, the resolution of those components from the interfaces that you work with within your application. A lot of times, especially for smaller programs, you can implement this design pattern within your own code yourself if you wanted to. Like I mentioned previously, the examples I had of that database service, they're an example of a type 1 IOC where we supply any dependencies that our components need in order to function within the constructor. There's two other types of IOC patterns that you could also follow as well for dependency injection. You could have a setter pattern as well, where if you have any properties that are defined within your components, they could be directly set on the property itself as well. If you have any dependencies that are not, how should I say, not required. If they're optional dependencies within the component, they could be set that way. If you want to follow this kind of if you want to follow this kind of design pattern within Acumatica customization code, it presents a couple of problems, particularly with writing, graph extensions, writing custom business logic to existing screens, or perhaps you have new PX graph instances that you're defining for any new screens that you're adding to your Acumatica environment. Or you might be, modifying existing DAC fields, adding and extending out new attributes, or even custom attributes for the various different event subscriber interfaces that you can implement within those field attributes. If you want to be able to supply any external services to those Acumatica components, it presents some issues, since generally developers of Acumatica components don't actually create and maintain those object references of the Acumatica components themselves. They generally rely on the framework itself to create those objects and maintain those references within memory. So if you want to be able to actually pass along and reference any external services within your customization code, then to be able to do so properly, you can work with what Acumatica works with on the back end for its IOC container, which is called Autofac. Now, IOC, mentioned that a couple of times before, what it stands for is inversion of control, or it's also a general developer term, not just related to dependency injection. It just refers to the process of taking control from within a component and inverting it. So taking control of creating and resolving any dependencies that are used by components and taking them outside of the component itself and relying on an external framework to be able to do that functionality for us, which is where Autofac comes in. And Autofac provides an IOC container that allows us to register interfaces as well as various components as well, and to be able to resolve those components, those external services throughout all the different places in our application that we need to access them. And Autofac has various different features and functionalities that are useful, such as component registration for internal, external assemblies, auto selection of interface implementations, activation events, so events that can trigger when we register and resolve services that we want to use for our application. But the main focus for today's session is going to be the flexible module system. So this feature within Autofac allows us to create base classes, or I should say child classes of the base module within Autofac. And Acumatica framework has various different mechanisms in place to be able to load those modules, take the load method and call that load method to be able to build the IOC container that you can then work with throughout the rest of your customization code. And so to be able to illustrate that point, I'm going to go ahead and exit out of the PowerPoint slides and then go into a demo of the logger service that I have for today's session. So before I go into the example that I have on the website, I'm going to have little showing of my Visual Studio solution right here for the code that I'm going to be demoing off. So the main actual Acumatica customization code I have right here, I have two different graph extensions. I have a graph extension of the sales order screen through this SO order entry extension. And I also have a extension of the purchase order screen with this purchase order entry extension right here. And with this logger service that I'm demoing off here, it's basically just any other logger that you might use in your application code. So if you want to log any events or any changes to anything that happens within your code, we simply have this iLogger interface that we reference within our graph extension here. Again, for the sake of simplicity for today's demo, it's a very simple interface. It just has one method that it implements through the interface called write. Does not return anything through the method call. It just simply takes in a string as a message. So no special functionality for today's session as far as being able to have different levels of writing like an error or a warning or anything like that, although could of course extend that out in the future if we wanted to. Just to give an example of what we have with this particular code, I have with this iLogger interface, I have two different implementations of this logger that are designed to work in different contexts depending on the Acumatica environment that we have our site deployed in. So the example I kind of have here is imagine that you are developing a customization project. You might be working off of a local environment, a local development environment where you have the Visual Studio solution like this, and you have a website that is set up within IIS, a web server that's just deployed on your local machine. So we just have an example of an Acumatica website that's deployed on localhost on the machine that I'm presenting on today. And if you're developing off of a local machine, you might want to have a different logging functionality, say in a development environment or in a sandbox environment, versus how you would want the logging to work if you're in production or some other environment for real. So the example that I have for today's session is one where we have a text logger that we use for a development environment. So we have it so that any output that we want to write to our log will essentially go to an external text file that's saved within the file system on the server that's running Acumatica. And we have an example of a PX logger. So we have the ability to change the implementation of the iLogger service that we register. that we register for our production environment so that it uses the existing pxtrace write commands for logging. So that way, if there are any issues within our customization code within the production environment, we can simply have Acumatica users go through the standard process of being able to go to the trace page, compile, and report any issues that they have with the customization code to support for services to take care of, as an example. So to show off the actual logging functionality here, I simply have an event handler set up between the two graph extensions for the sales order and purchase order screen, just set up so that we have a field updated event handler right here so that the write command gets called when the order description on the SO order and the purchase order get updated. And I have the application settings set up on our website set up in such a way that it's going to write that log file to the logs folder on my local machine. So if I update this sales order right here from new sales order to old sales order, update that and save. If I go back to the logs folder, you see that we have a new log.txt file right here. If I open this up in Notepad over here, you can see that we have an updated order description right line right here with the new sales order description, which is just old sales order. And I can also do that on the purchase order screen as well. If I have a purchase order, and I update the purchase order description and save. If I go back to my Notepad++ screen, you can see I get a reload prompt right here since this was modified by a different program, which it was. And then I get an updated order description here as well with the purchase order. And I also have a line number right here as well. It's a 3 and 4 right here. It'd normally be 1 and 2, but I think it updated previously since I was testing this code before the start of this presentation. And that particular line number is going to be an example of how Autofac manages and resolves object instances of services within its IOC container based off of how we have what are known as instance scope methods set up within the container builder within the IOC container. So we'll be showing that off here within this service registration code. So in order to actually register any components that we're going to be using and implementations of interfaces for those services, we create a child class of this module right here, which is one of the classes that's specified within Autofac. The standard convention is just the name of this service registration, although generally doesn't matter what you name the class. The only requirement that we have for working with Autofac's IOC container is that you implement an override of the load method from the base module class, and that takes in as a parameter this container builder class. You don't have to worry about calling the base method for load. The way that Acumatica framework works with Autofac is it's designed to call load on any modules that are registered within any DLLs on the bin folder of the website. And through calling the load methods, it will slowly build up the container builder that it maintains through Autofac's lifetime scope. And so to be able to change and determine the implementation of our logging service from within our website, we actually worked with the application settings that are defined within the web.config for our website instance. So if we go to our website folder over here, have this CC25. So if we go to web config, we actually have within here the configuration app settings tag right here. We have all of the key value pairs right here, all of the ones that Acumatica works with by default. But we also have the ability to add our own application settings that we could use within customization code as well. And so in particular, we've added 2 new settings right here, one for logger type and one for log file name. So this logger type will be used to determine what version, what implementation of our logging service that we want to use on the website. And we also have a log file name here as well to be able to determine if we're using the text logger where the log file should be output to with the path and the file name right here, which is what our application, what our customization code does right here. So we work with the web configuration manager. We have some static properties to be able to reference the application settings based off of the key values defined within the web.config file over here. So we get the logger type, the log file name, and then we have a switch case that we have defined right here. Depending on the logger type, we determine what implementation of the logger service we're going to be registering within Autofac's IOC container that we're going to use throughout the rest of our customization code. So you can kind of think of this switch case as being sort of an implementation of a factory pattern where we're determining what service we want to resolve within our application depending on a set of parameters which are supplied by our application settings. And so in this case, since we're using the text logger, since that's what we have specified within the web.config, we're going to be making some method calls to the container builder over here to be able to register that type as an implementation of the iLogger interface, which is what we specify with these two calls to the builder, to the builder field right here. And an important thing to note with working with this particular implementation of iLogger is that it does have, in order to be able to actually create an object instance of this class, we have to specify the log file name, so the path and the file name that is going to be output, that we're going to be using to output all of our logging data. So that's going to be set into an internal field on the text logger class right here. And this text logger has a implementation of the write method that it has to implement as a result of implementing the iLogger interface. So we have an implementation of this right here where we just open a stream writer, supply the log file name. It's designed to just append off of any existing files that might already be at that specified location. And then from there, we just do stream writer's write line method, and then also increment this line number right here. So any calls to the write line method right here, we specify the line number at the very beginning and then increment, and then each successive write line call, we're incrementing that line number integer. And this is just to show off an example of how we are managing resolving and passing along object instances of classes to all the different parts of our application code. So we have this with parameter call right here, specified with this type parameter from the log file name. So this log file name is a string. So this is an example of when working with Autofac's IOC container. If you have any dependencies that require some parameter with within its constructor in order to actually create an instance of that object, you have a couple of options for how you pass along those parameters for your classes. You can either choose to supply those parameter at registration time or at resolution time. In this case, we're choosing to essentially supply that parameter at registration time, basically indicating that whenever we need to create a new instance of this service, we're always going to pass along the same parameter for this text logger in order to actually create an instance of this object, which is going to be the one that's specified within this log file name right here. And we also make a call to this single instance method right here, which is what's known as an instance scope method within Autofac. The two main ones you're going to be working with, well, either going to be essentially defining a single instance, which is going to be a way of working with singletons within Autofac's containers, or you're not going to basically specify any additional method calls on the container builder, which will basically indicate that anytime you're resolving a service within application code, it's always going to create a new instance of that object every time you try to resolve that service. And so what this means for our customization code is that when we have when we're working with this logger through graph extension or graph code or an attribute that implements an I event subscriber interface, we're always going to be basically returning back the same object instance throughout all of our customization code, which could be very useful in certain cases. You might have some sort of external service, again, that might connect to an external database, or maybe you have some sort of new control that you are interfacing with an AI service that you want to be able to, say, open a connection for and then maintain that connection state throughout the entire lifetime of your website. So as long as your website's running, you want to be able to maintain that connection without having to tear down and build up that connection state every time you want to use that external service. Then you could have a service that's registered here within Autofac's container, registered as a single instance, and then the first time your application needs to reference and use that service, it's going to run the constructor code to build that object, and then afterwards, Autofac will do the work of maintaining that object reference within memory, and any other part of your application that needs to use that service can just work off of that same object, which is where that line number reference comes in. So you saw before, previously we had line number 3 that was referenced on the sales order screen, and then line number 4 that was referenced on the purchase order screen, just to indicate that those two graph extensions within our customization code are all working off of the same object reference of that text logger within memory. And so that's an example of how the text logger works within this example. If I want to show off how the PX logger works, then I can just simply go to the web config over here. And instead of having a text logger defined as our implementation of the iLogger service that we use within our code, I could simply change it to PX logger right here. So I'll change that in the web config and save, and go ahead and reload our website. And while that's waiting right here, Vlad, I don't know if you have any questions within the Q&A, or if anyone wants to ask any questions right now while we're waiting for the website to reload.
Yeah, let me check it out. No questions, just an object reference error when implemented iFiles dialog extender at graph. Oh, in the Q&A portion, in the chat, there might be some questions. Okay. I didn't check yet.
Reference error when implemented iFiles dialog extender at graph. So yeah, I'm not entirely sure what that's referring to. I don't know if you have an example of a service that you're trying to work with within your own customization code that might be giving you that error, or if that was like something that was just seen within my environment that I might have missed.
I guess another question is, how do you have a dark mode or a dark theme?
Yeah, it's funny. I was just thinking about that too. That's just an extension that I have in my browser. I'm just using a Dark Reader for Edge right here. There's a version of that extension that's also available in Chrome and Firefox and all the other major browsers. Sadly, there is no official dark theme within Acumatica, so I just use that extension just to be able to have some kind of dark mode that I could use just for everyday purposes.
Cool. Other than that, yeah. No other questions.
I don't really have any other like custom like CSS or anything like that. Actually, just within Dark Reader, I have it set up to use this Filter Plus theme right here, since with a dynamic within Acumatica, it kind of has some issues with being able to show like text boxes properly and whatnot. And maybe definitely no promises there. Maybe in the future we can get some kind of official dark mode going for Acumatica, but nothing for the time being. But yeah, since we have our website reloaded right here, I'll show off sort of the same process that I went through previously with the text logger with the PX logger instead. So I'll update the description right here from old sales order to new sales order. I go back to the tools and the trace page. You'll see I basically have a warning message that's written to the screen right here. So our warning message contains the type of the PX graph that this call comes from. So in this case, SO order entry with the same message that we had previously. So updated order description, new sales order. Then same for the purchase order as well. If I go to the purchase order screen, updated description for an existing purchase order, go to PX trace. Same thing here. So instead, we get the reference to the name of the PX graph that the call came from. So PO order entry, and then with the same logging message that we had before. You'll notice if we go back to our log.txt file, no updates. So with a simple change to our application settings in our web config, we were able to change out the implementation of our logging surface from using a text-based logger to just using Acumatica's regular PX logger. So an example of how our customization code would look if we were running this on a production environment rather than a development or a sandbox environment. So just to show what that PX logger code looks like on the back end, again, within our service registration module right here in our load, this code would have basically re-executed, reloading the logger type, and within our switch case, within our factory pattern right here, would have seen that we are working with a PX logger instead of a text logger. We also have it basically set up as a default as well. That application setting was had some sort of undefined input. We would just default to using the PX logger instead. And within our container builder calls, working within Autofac, we have as a registration type, we have PX logger defined as an implementation of our iLogger interface right here. So if we take a look at the specific code for that PX logger, here is what the code looks like. It's also an internal class that implements the iLogger interface, so has implementation of the write method that we have defined within the interface. It just simply makes a call to PX trace to its static method for write warning. Actually, basically taking a instance of the graph that we save to a private field within the class, calling get type, and using that as the prefix for the message that we write to the log output. And in order to actually get that PX graph context within the PX logger class that we have right here, we have PX graph defined within the constructor of the class right here. And then within the constructor code, we just set that graph instance to an internal property, an internal field that's defined within the PX logger class. Which also brings up another good point as well, since you'll notice that within our container builder, unlike what we have done previously with the text logger, where if we had any required parameters for being able to create an object instance of any classes that we've defined within the IOC container, previously we had to specify with parameter in order to make sure that Autofac's IOC container can actually resolve those services correctly by the time we need them within our application code. And we haven't done that here at registration time. And so in order to actually get that to work properly, that's actually something that's provided for us by Acumatica framework with this inject dependency attribute that's supplied within PX data. Now, I haven't gotten into the specifics of this previously as well. So as far as actually being able to inject the dependency of our logging component that we use within our graph extensions, all we've done here is essentially specify a property within the component that we're working with, in this case, a PX graph extension. And it can actually be with any access modifier within the class itself. So it could be a public property, or it could be protected or private or internal or any combination of such. All we need to do to make sure that that logger dependency is available within the customization code is just to specify inject dependency as an attribute on the property here. And one of the benefits of using this attribute that Acumatica framework provides for us is that it will also provide any Acumatica specific context to our dependencies if they require them. Depending on where the property is defined in, you can get access to different components, different contexts of the Acumatica framework. So with working with the PX logger right here in particular, since we have this property defined within a graph extension, we have the option to be able to get the PX graph that graph extension is working off of. We can also get the graph extension itself if we wanted to. If we were using these particular services just directly within a PX graph, so just working off of a graph for a new screen that we're working with within customization code, also be able to get access to the PX graph context within our service. If we were working off of a custom field attribute that we're defining on a DAC, we can get access to the PX cache of that DAC, PX cache extension if that particular field attribute was defined on a field that was defined within a cache extension of a DAC, as well as the PX graph as well for where that cache has been, basically where the cache has been created for that PX graph. Basically any context that you would normally be able to access from the component that you're writing within customization code, you're also able to access within your service by simply defining that service as a required property within the constructor for the class. So yeah, that's just a high level. That's pretty much an overview of what I wanted to show off with working with external services within customization code. I'm trying to think if there's anything else I wanted to show off here as well. Xlogger. Yes, and that's actually the one other thing I want to mention with turning it back to those instance scope methods within Autofac. So previously we had defined within the text logger that it'll be a single instance, so it'll be a singleton where all of the references of that service that we're using throughout our application code are all going to reference one object reference of that text logger. With our PX logger, we have it defined so that it's basically just working with the default settings for Autofac's container builder, where basically every time you try to resolve that service to use through your customization code, it's always going to resolve a new object of that PX logger. So that's the object of the PX logger that we reference within the sales order graph extension is a different one that's referenced from the purchase order extension. And then that PX graph instance is going to be unique to the sales order and the purchase order screen. And that reference is going to be unique to that PX logger. And that PX logger, the objects of the PX logger are going to be unique to those two graph extensions and also any other component where we're referencing that particular service. Hence why we're able to see a different type reference within the message that we output to the logger for the sales order screen and the purchase order screen, like we see here. And that's definitely the recommended approach for anytime you have any sort of external service within your code that references any Acumatica context. Definitely want to make sure that we have the instance scope within Autofac's container to be able to use register, basically a resolve, basically resolving a new object reference per resolution of the service rather than going with a singleton pattern right here, because we did a single object reference like we did for the text logger right here, and we referenced a PX graph context over here. What could end up happening is that we have sort of a loose PX graph reference that is maintained within memory. So since that object reference of PX logger would be maintained by Autofac from inside its container, and that PX graph is used by that particular PX logger instance, you could run into problems where that graph instance never gets garbage collected by the CLR from within .NET. So it could lead to potential memory leakage issues. It could lead to potential issues where you have DAC graphs that are referenced on one screen that are also referenced by the PX graph that is referenced within this internal field. And so one could trigger updates that are still referenced by the other. And so the framework could detect that changes to the same DAC object in multiple graph instances have been updated, and then prevent you from saving and persisting your changes as a result. So it could lead to issues. So definitely want to make sure whenever we're referencing a Acumatica context within an external service like this too, that we're not working with a singleton pattern. So yeah, I think that covers it as far as what I wanted to do show off within this demo code right here. So I'll go ahead and go back to presentation from the screen and wrap it up with some best practices. In particular, just sort of when you might want to follow this design pattern within your own code, and when you might not want to. In terms of when you might want to use this, again, going back to sort of the beginning of the presentation, if you have shared functionality amongst multiple graphs and DACs within your project, requiring and maintaining object states. In particular, if we have different implementations of a service that we want to provide at runtime, again, maybe depending on our environment or application settings, like we had seen in the demo previously, of being able to have a different version of a logging service, depending on if we're in a development environment or a sandbox environment versus when we're in a production environment, or if we have any services that require connections to external platforms that make unit testing of components within our application difficult. We could choose to abstract the interface of those services out in such a way where we're able to mock those services for the sake of unit testing, and make unit testing of the rest of the components within our application a lot easier to implement. I think those are all examples of when you'd want to consider going with a dependency injected design pattern to be able to work with any external dependencies within your application code. Otherwise, when you might not want to go with this particular design pattern, within your applications, I think the advice I kind of like to follow within my own development is to keep it simple, stupid. So if you have some functionality that is only ever going to be like referenced internally within your own code, perhaps it's something simple that doesn't require maintaining object state. If you have some method that performs some sort of cost or price calculation that you might want to share between screens, but is otherwise fairly simple and doesn't require overloading with a bunch of additional parameters, or doesn't require interfacing with some external integration to be able to perform the calculation properly, you could just as easily implement functionality like that with just a static class and a static method where you supply in maybe a DAC object and various different float values for price and cost to be able to retrieve back the calculation that you need to for your screens. If you could do something like that, don't see there's any reason to go with a DI pattern like that. If you could go with an approach that's simpler to maintain and doesn't require as much software architectural abstraction to be able to implement. And in general, if you have any components that don't necessarily require unit testing, it might also be perfectly fine just to have, either static implementations of any functionality you want to implement within your code, or perhaps just a simple abstract class, perhaps an abstract graph class that you could then reference between multiple graphs or graph extensions that just have base functionality within that class. That could also be a good example where you could just simply go with that without having to go through the trouble of working with Autofac's IOC container to register and resolve external services. Yeah, that about does it as far as the main part of the presentation. So I hope you guys enjoyed it. I'll go ahead and go into a Q&A right now and see if anyone has any questions.
Yeah, but definitely start with the Q&A window. Got a couple of questions lined up here.
Yep.
Let's start from the top. Not sure if you already answered this, but can you expand on how the PX logger gets the PX graph as a dependency automatically?
Yes. Yeah, that was I think one aspect where I kind of wish I sort of explained that a little bit more concisely from the top. So how it's actually able to get PX logger as like so yeah, expand on how PX logger gets PX graphed as a dependency automatically. That is something that functionality is actually provided for us through this inject dependency attribute that's actually defined within PX data within the Acumatica framework. So what Acumatica framework will do when we start a website for the first time is it's going to go through all of the libraries that are defined within our the bin folder of the website. It's going to see within those libraries if we have any service registration modules that inherit as a base class the Autofac module. And then we'll register any of those services within the container builder. And then when we actually get to the part of our application code where we actually need to resolve any services as dependencies that need to be injected, Acumatica framework will go through, see if there are any properties within any of our components that have inject dependency as an attribute. And then again, depending on the context, it's going to supply the context as parameters to the constructor of any of our external services when it actually needs to resolve, when it needs to create any new object instances of those dependencies. So that's all taken care of us by just this inject dependency attribute right here. Hopefully that makes sense.
Cool. And then next, where can someone get info about iFile dialog?
iFile dialog. If you don't mind me asking, iFile dialog, is that an interface that's actually defined within Acumatica framework, or is that defined somewhere else? Let's see if I can find that. File dialog. It's an iFile dialog grid.
Or it might be L file dialog. Let me check.
I think it should be iFile dialog. It should be an interface. Let me see if I can actually find that from within at least the code repository that I have um, within the website that I'm working off of. I can't seem to find it. Unfortunately, I can't really seem to find it. I don't know about it off the top of my head. iFile dialog. I feel like that sounds like it's Acumatica. I don't know if that's related to like the pop-up screens, like pop-up panels within Acumatica screens. I could take a look at that later in the future and give you a response there. But I wouldn't be surprised, just like help.acumatica or community.acumatica, if you search iFile dialog, you could probably find some more information on that.
Alrighty, the next one. Could you share a sample or a best practice to use dependency injection to consume web services from a graph?
Yeah, I think best practices. Yeah, in particular, if you have like a web service, especially any like web service where you're making some kind of REST API call, maybe either maintain a connection to the web service or you set up and tear down that connection on like a per request basis. I mean, honestly, I feel like best practice for something like that, especially from a graph, would just be to follow similar to the example for the logger service that we had from today. So you'd have, your Autofac module here. If you have that web service, you would have an interface for any methods that you would want to use to work with the interface, to work with the web service, register it here. And then if you had a PX graph, and again, the example from today's session was with a graph extension on the sales order, purchase order screens, but you could basically do the exact same thing that we've done on the PX graph extension here, just do it on a PX graph instead. So it would just simply be a property that specifies the interface and that has inject dependency as an attribute. And then as long as you have that little bit of like boilerplate code defined within your customization code, you could just work with it throughout the rest of the class as you need to.
Okay. Other than that, there aren't any other questions that I can see.
Okay. Yes, I think we have some questions that were asked within a chat instead. Um, But yeah, actually see, yeah. See if I can start from the top. It actually seems like we got a couple of AI note takers over here. Actually quite a few. I don't know if I'm gonna be able to go over all of these questions. I'll actually start kind of closer to the bottom here because I think there's some interesting questions right here. Should start with this one. Will it be needing Autofac after moving to .NET Core version of Acumatica? I've heard about. I believe the DI is built into the framework now. Yeah, even after we move over to .NET Core, Autofac itself has versions that are designed to work with the most recent versions of .NET Core. So if you have any dependency injected services that are designed to work with Autofac, they should work just the same before as they've worked previously with the versions of Acumatica that have targeted .NET Framework. There was actually something else I wanted to highlight during the demo. In particular, since we have this web configuration manager, we have app settings right here. This is actually something that's marked as an error within core compat, since this particular static class is not going to be available to us when we transfer over from Acumet or from .NET Framework into .NET Core. This would be like an example of kind of single responsibility within like object-oriented programming, where I kind of want to have all of these services defined right here because when we actually make the transition away from .NET Framework to .NET Core, we can easily change all of these references just from within one place of our code without having to have like these references to like the web configuration manager app settings referenced throughout like your entire code base. But that's a little bit of a digression. Point being, yeah, if you're working with Autofac for any dependency injected components, you shouldn't have to worry about upgrading anything when we make the transition away. From Sergey, so when using singleton services for state sharing, you're aware of the behavior in multi-tenant and cluster environments. Multi-tenant environment, the same instance of a singleton service is used for all the tenants. So you have to take extra care when accessing tenant-specific data. It's a good point. So in a cluster environment, obviously each node in a cluster will have its own singleton instance, so the state will not be shared between the nodes, leading to unexpected behavior. Yeah, thank you for bringing that up as a point, Sergey. Basically, just I think it's important to think about that in particular when working with singleton services within customization code. Basically, any the way that customization code is going to work is going to work on essentially a multi-tenant basis, where if you have a graph extension that's defined in your website, there's no mechanism in place as far as being able to choose whether or not that customization code is loaded for one tenant in your Acumatica environment versus another tenant. And the same goes for working with services that are registered and resolved within the Autofac container as well. So if you have a singleton service, you want to make sure that any sort of logic that you have defined within that service is going to be okay to use within a multi-tenant environment. Actually, from survey, she's saying need Autofac mover. Yeah, the built-in DI framework is an abstraction which supports multiple implementations. Autofacts, it's one of those which Acumatica uses. Yeah, okay, I might have misunderstood the question from earlier too. I think that was about specifically if you're using, Microsoft's built-in like dependency injection framework. It's timeless personally. There's which wasn't aware of off the top of my head whether that is something that's only available within .NET Framework and not necessarily a .NET Core. I mean, if it is only available in .NET Framework and we make the transition away in the future, then yes, you'll want to transition away from using Microsoft's built-in dependency injection library and go with something like Autofac instead. Or of course, if you want to use something else, you could just as easily use your own library for an IOC container for any external services and supply the DLL for that, within your customization code and have that published to bin within the website as well, if you prefer to do that. So I got a couple more minutes. Any other questions I can answer?
Oh, let me check the Q&A window.
Just one more of the Q&A. how to use interface object at graph constructor. Oh yeah, I think that's also a good point. Yes, one last point, I guess, before we end today's session. So the important thing to remember with being able to use Autofac's IOC container to resolve services, you cannot do it directly within the graph constructor because of the way the inject dependency attribute works. So the Acumatica needs to be able to actually create an object instance of that PX graph before it's actually able to inject any of the dependencies that are needed within that graph object. So if you need to be able to use any services that are registered within the IOC container, essentially within the graph constructor, what you should do instead is do it within basically within initialize. So you would have a PX graph that implements the, I believe, iGraph initialize interface, and then you would implement the initialize method, and then essentially if you need to use that service at any point when like the object's like created, essentially when the user navigates onto the screen for the first time, then you would do it within the initialize method instead. So yeah, I think it's good. Right up on time. So I think that's a good place to leave it and to wrap it up.
Awesome. Thanks, Nicholas, for presenting. And as a reminder, this presentation will be available on Community. It has been recorded. And yeah, thanks everyone for stopping by.
Yep. Thanks everyone for joining. Hope you all have a good day. Take care.
See you later, everybody.
See ya.